Hello, my name is Benjamin Shannon, and today I'm going to present to you on behalf of myself and my co-author, Dr. Jayantha Kodikara, on effect of wet-dry cycles on soil moisture and void ratio of a silty clay. Introduction. Soil experiences changes in density and moisture content due to shrinkage and swelling caused by seasonal variations in climate. During periods of wetter months, the soil swells where the density decreases and the moisture content increases. During warmer months, the soil shrinks where the density increases and the moisture content decreases. Seasonal movement can have an effect when infrastructure is placed in the soil medium or on top of the soil medium. Wet-dry cycles may also influence many other soil properties such as mean stress, tensile and compressive strength, suction, hydraulic conductivity, and cracking area, and so forth. So this paper consisted of two different parts, a field part and a laboratory testing part. So for the field methodology, a natural silty clay soil was exhumed from the field around a pipe and instrumentation was installed on the pipe. So the instrumentation was used for another project, but in this project, we excavated the soil. And then once the pipe was instrumented, the soil was backfilled and the bitumen layer was reinstated on the surface. And after that, soil samples were taken and tested by a contractor. And then the backfilled soil was excavated 8 months later for subsequent testing. So the soil laboratory testing was conducted by us. So here's some of the standard tests that were conducted during the testing. For more information in the paper, there's a few more other tests, but these just include, say, the Proctor, the liquid limit, Atterberg limits, and odometer testing and triaxial testing and so forth. So the methods for the wet-dry cycle testing, the soil was dried, crushed and sieved. All soil specimens were mixed to initial moisture content of 16.2%. Then the specimens were statically compacted to 3 different compaction energies. That was 500 kPa, 2000 kPa and 8000 kPa. The specimens were coated with hand spray plaster, which looks like this. So the hand spray plaster is good because it allows moisture to go into the soil sample and go out of the soil sample. And dry cycles were conducted in a constant temperature room, whereas wet cycles were conducted in a humidity chamber or directly in water. The density or void ratio readings were gathered from an immersion method. So that's in the picture here, where after the specimens were coated, they were dipped in this water specimen, and that the buoyancy of that would change the balance and we would get a density based on that. And here's just a picture of the specimens during a wet cycle. So this is a 500 kPa sample. You can see there's lots of clods still in there, as opposed to this 8000 kPa sample, which is pretty well compacted. So the good thing about this, it means we could get testing results throughout the whole shrink swelling cycle or wet drying cycle. So from field tests, the results from the contractor show soil was compacted to wet of optimum. That's in this graph, and I'll go through it here. So here's the Proctor standard compaction curve. These points here from the the contractor's compaction results. So it varies from about 0.4 all the way up to 0.7 in void ratio. The moisture ratio, which is the gravimetric water content multiplied by the specific gravity. So this is moisture ratio is just a function of the water content and the specific gravity. And then results from 8 months later show the moisture content and void ratio both have increased. So that's these points up here. And I'll go through that in further slides. So we can assume for these period of 8 months that are winter months that occurred, because this was in Australia and Victoria, in Sydney. So in the winter months, we can assume that a wet cycle occurred. So the average properties after compaction and 8 months later are shown below, and they're also in the paper. So the moisture content changed by about 7%. And the bulk dry density reduced and saturation remained about the same. So the results of the laboratory testing on the wet dry cycles, The test results varied from 3 to 40% gravimetric moisture content changed. The first few cycles show significant movement, and the loose compacted 500 kPa specimen had high movement from the initial compaction level. I'll just show you that on here. So you can see this is the initial point of the 500 kPa compacted sample. And the first few points went up along here and down along this curve and then back and so forth until they got to this stabilized curve, stabilized wet drying curves. So that's the fourth drying cycle and the fourth wetting cycle. The dense compaction, the 2000 kPa and 8000 kPa, they show a lot less movement, whereas the medium compacted 2000 kPa maintains its wet dry paths. So you can see here where its initial one, it's maintaining that wet dry path. Some of them went up a little bit higher, but the rest it just maintains along that wet drying path. And the same thing we can see for the 8000 kPa sample, where this is its initial point and it consistently shrinks and swells along this saturation line up until about this 0.3 moisture ratio and void ratio. So the results. So the comparison between the field and laboratory, the soil was compacted wet of optimum and experienced swelling to a higher void ratio and moisture content. So the 2000 kPa and 8000 kPa specimens show good comparison with the field results. So you can see here, that's where the swelling range went from about 0.4 all the way up to 0.8. And you can see here, if we draw an area that showing the results, they're around this area here. So they're in good agreement with those 2000 and 8000 kPa results. It's expected that the soil underwent a wet cycle in the field. And yes. And so the results from the wet dry cycles correspond well to the field results. A high level of compaction may result in less void ratio movement, as shown by the 8000 kPa. And a line of optimums between all of those three compaction levels was not found. So they all didn't go to the same shrink swelling curve or wet dry cycle curve. So in conclusion, so the following are some recommendations for. So the following are recommendations from the final findings of the project. So further testing is required to determine the wet dry curve trend for different soil types. Changing the initial compaction point should be examined on the way it changes the wet dry curves. Extreme wetting and drying cycles simulating high rainfall or drought to see the variation in soil void ratio. Increasing the number of tests could also be beneficial, as well as measuring soil suction throughout testing. Disturbance of the soil in reaching a stabilized curve would be beneficial to validate the soil shrink swell theory. Thank you for listening.